What's up, team? Today we're going to introduce one more triangle congruence criterion. It is our final one. Don't worry, no more surprises. This one I'm going to spend a little more time on. I'm going to do a little bit of a proof to convince you that it works and why it works, but you're going to use it the same way you've used all the other ones. So at the end of the day, you'll be able to add this one to your tool belt. You already have 4 that work. You're about to have 5. So when you see a triangle that looks like what we're about to talk about, you can use this new triangle congruence criterion. So here we go, one more criterion, and we call it Hypotenuse Leg Criterion. You'll see more why. It's not very creatively named. And here's our learning target. It says, I can understand and utilize the hypotenuse leg criterion to show that 2 triangles are congruent. Okay, on the board behind me, I have 2 triangles. They're both, they have an angle in common, so that I have that part there. They have 2 pairs of corresponding sides that are also congruent. So if we're using the information we already have, I think we can see pretty quickly that these triangles should not be congruent based on the information that we've discussed previously, because we have a side, and an angle, side, angle, or we can look at it the other way and it's angle, side, angle, side. We know that when we have the no word, they are not congruent. I made that very, very clear, and I meant it. But there's an exception, and we're about to discuss the exception. So this exception here involves right triangles. So it's not just that these 2 angles are congruent corresponding angles, it's that they are right angles, and that's hugely important. It's a big deal in this case. So we're going to utilize Pythagorean theorem here. So we know that when you have a right triangle, a squared plus b squared equals c squared, where c is the hypotenuse, a and b are 2 of the legs. So in this case, the length of a squared plus the length of b squared equals the length of c squared. So I'm gonna capture that over here. A squared plus b squared equals c squared. Okay, in our second triangle, we can say the same sort of thing. We can say that d squared plus e squared equals f squared. Okay, no real surprises. I've just shown you Pythagorean theorem that you've done 100 times before, right? But what's different about this one is we are given the information that A and D are congruent sides, meaning those side lengths are identical to one another. In the same way, the hypotenuse is, hypotenuse, I don't know how to say that. Hypotenuse of the hypotenuse of both triangles, C and F in this case, are also congruent to one another, so they have the same length. So with these equations over here, I'm going to do a little bit of substitution. We know that D has the same length as A, so I'm going to substitute A in for D. We don't know anything about E at this point, but we do know that F and C are the same, so I'm going to capture that here. So now we have these 2 equations. A squared plus B squared equals C squared, and then we have A squared plus E squared equals C squared. Okay, we're going to do we're going to do some more substitution here. We know that C squared equals this stuff. We know that C squared equals this stuff. So I'm going to take these 2 chunks and set them equal to each other, just using substitution. I'm essentially saying that C squared equals C squared, but I'm using the values here. So A squared plus B squared equals A squared plus E squared. Now, what I can do here, I'm going to subtract A squared from both sides. And I learned that B squared equals E squared. Take the square root of both sides. And I learned that B equals E. Okay, well, what value does that give us? Well, let's look back at our picture. And we see that B and E are the 2 sides that we don't know anything about. So we just showed that they have the exact same value, or the exact same length. So now, looking at these triangles, forget about side angle, because really what we have here, because we know that they are right triangles, we have a side situation. We have 3 pairs of corresponding sides that are congruent. So these triangles are indeed congruent. Now, what if you come across a situation like this out in the wild while you're doing some practice problems? Do you have to do all of this algebra in the midst of geometry class to show that the 2 triangles are congruent and then say side at the end of the day? No, fortunately you don't, because we know that this is going to work every time. Like, we didn't even use numbers in this case. we just used generic letters, and we followed Pythagorean theorem appropriately, did a little bit of substitution, and found that the other two legs are going to be congruent to each other as well. So we call this theorem, or this criterion, we call it Hypotenuse Leg Criterion, or HL. And the reason we call it that is because we have both the hypotenuse of both triangles are congruent to one another, in addition to one of the legs, one of the pairs of legs. And the second pair of legs we just don't know anything about. That's okay. So this only works. This only works when you have a right triangle, or a pair of right triangles. If you don't have a pair of right triangles, you don't get to use this. But if you do have a pair of right triangles, and you have one pair of legs that's congruent, and the hypotenuse of each triangle that's congruent, you can say these two triangles are definitely congruent because of HL. And if you want to see the whole word here, it's hypotenuse leg. And that's the criterion. So instead of side, angle, side, all of those, we get to say hypotenuse leg. And that's the name of this one. Cool. Your practice problems today have some problems like this. They also have some other ones just to mix it in so you don't get to write HL on all of the answers. But make sure to check those out. Let me know if you have any questions.